Welcome back everyone to the Hello World Guy, and in this video, this is part number 5 of the 3 platformer series. In this video, I'm going to give you a brief overview of creating some different kind of obstacles for our game. So the first one that I want to do is this purple looking thing. I have already added a cube and scaled it according to my preferences. You can see the values here. What I have done, one more thing, is that I have gone ahead and let me delete this. I didn't really need that. I created it for testing, just a physics asset. Anyways, what I have done is I have created a material for this as well called purple, which is not smooth at all. And this material and what this is supposed to do is actually supposed to be a scaling obstacle. So what happens is that after a small period of time, it will scale down to a very small size until it is impossible to walk on. So yeah, we basically want kind of a that kind of system. So yeah, that's pretty nice. So let's get started programming it, because currently it's just a normal kind of platform in the game, currently does nothing. But yeah, we want to get that. I'm going to give you an overview of creating one obstacle, and maybe you can create more obstacles on your own, and we will also create a basic point system in this video. So with this done, what I'm going to go is I'm going to select this object, and then I'm going to go under my script folder, right click, create a new C# script called let's just call it scaling obstacle. Just going to name it the same thing, obstacle. All right, and what I can do is I can let it compile. You can see it's compiling down here, and once it reloads the assemblies, all you need to do is just drag the script on the scaling obstacle object, just like that. And what you can do is double click to open it up in VS Code, and I'm going to remove the two using tags up here. Then I'm going to remove the start method as well. Then I'm going to remove this comment because we don't really need that. Anyways, in here we are going to create a serialized field, a private vector3 called new scale. Okay, so this will basically be kind of a the reason I'm actually doing this is so that we can actually make this scale obstacle become bigger as well as smaller. By default it may be smaller, and then we will make it bigger. We can do whatever we want with it, so it's not really kind of like a scaling obstacle. And I'm going to have a serial, it can be anything if you want to scale it like in intervals. So I'm going to create a private float here called called scale delay. All right, and another serialized field here called a private float called scale speed. All right, I'm going to not going to set any of these by default. What we will do is that we will actually, let me have the we are going to create a coroutine here. So let me just use system.collections up here using system.collections, and that allows us to create a coroutine here. We are going to create a private I enumerator called this is a coroutine which can be executed at a particular time. Very nice functionality. And I'm going to just call it scale. All right, all right. What we want in here is that you may say something. Let me just first of all, let's just go into the start method. Let me just add the start method in here, start. And what we want in here is that we want it to have a I'm just going to start the coroutine of scale here, and that looks nice. Okay, what we want is that in here I'm just going to say yield return scale okay, yield return new wait for seconds. So this will wait for a particular amount of seconds, and we are just going to give it a scale delay as the amount of seconds we need to wait for. And this looks pretty nice. We have got a wait for setting here, and what we want is that we actually want to scale here. Currently we will just scale instantly. We will add a delay, a speed to the scale shortly. What I'm going to do is I'm just going to say something like transform dot scale is equal to actually we are not going to do that, of course, because we are also going to have a private bool here called scaling to new, which will represent if we are scaling to the new or not. And this is by default going to be true, because of course we are first of all at the default scale and we want to change to the new scale. So I'm going to say of course we need to memorize the old scale of the object as well. So we will have a private vector3 here called called all scale all scale, which we will set in the main method. We will just in the start method we will just scale all scale is equal to transform dot scale dot local scale. By the way, this is the local scale of the object, because you can't get the global scale. You can, but you cannot modify it. So we are going to go and say transform dot local. We are going to check if scaling to new. What we are going to do is that we are going to say transform. We're just going to say something like transform dot scale local scale is equal to new scale currently. Just let's just do that, and else we are going to say transform dot local scale is equal to all scale. Let's just say that. And yeah, that looks pretty awesome. I'm going to move this yield return to be the start, and you can see that this seems to be pretty much all right. So what this should do is actually it should work, but of course we need to set our scaling to new. Scaling to new is equal to not scaling to new. We will just invert whatever it is right now. So just a brief overview, we are setting our new scale, scale delay, and scale speed as variables that we can modify in the Unity inspector. Then we are having a private vector C called all scale, and a bool which determines whether we are scaling to the new scale or the old scale. And in the start we just set our all scale to whatever the scale currently is, and we start the routine of scaling, which waits for the scale delay. And of course in the end there is one thing that we want to restart this coroutine again, saying scale delay. All right, and you can see it's scaling to new. Okay, not really scale. Okay, if our scaling to new is, then we set it to new scale, else we set our scale to the old scale, and then we invert the scaling to new. Pretty much fine. This should work, so let's test it out in Unity. Alright, so inside of my Unity scene, I have added the scaling obstacle script to this, which has got a new scale of, on the X is 0.1, and on the Y and Z it is the same as the original. And then we have got a scale delay of 5 and a scale speed of 2. Of course the scale speed currently does not function, but let me just hit play to see how well that goes. So what you should see is that 1, 2, 3, 4, 5 seconds pass, and yeah, it becomes smaller. I can still stand on it if I really make it, but if I move a little bit to the left, then I cannot stand anymore. Okay, so if it suddenly disappears, then okay, and then the game is pretty much over. So yeah, this is pretty much functioning. What we want to do is actually make it so that it kind of grows, which it currently is not doing, so we want to make it that way. Now for this, what you might do is create a another vector tree here called target scale. Okay, and whenever we do this, we just set the target scale instead of this. So I'm just going to change the target scale here, and then we can use the we can use the update method to actually handle this. So I'm going to add in an update method here, and here we can basically transition to the target scale. So if I go ahead and say vector3 dot lerp, you can see that we have got this here, and start value returned when t is equal. So we want to give it a start value, which currently so for that we will need to have two variables here. Let me just remove this. Let's have it in a separate line, a private vector3 called I'm just going to call it, of course it's going to be our target scale, and one is going to be our original scale. Okay, what we are going to do is that each time we do this, we set our original scale is equal to our transform dot local scale, so whatever scale we currently have got. And then what we do is that we lerp from our original scale to our other scale, which might be something like our target scale, and then we need to give it a float value. So if I give it a value of 0, it will return the original scale. If I give it a value of 1, it will return the target scale. So basically need to interpolate this value so that it gives us the desired scale over a series of time. So what you might do is that you might create another variable here, a private float called start time, I guess. And what happens is that whenever we do any of this, we set our start time is equal to time dot time, which gives us the current time of the game. And what we do is that that's basically say time dot time minus our start time. Well, that should work, but of course we need to set our transform dot local scale is equal to this. So yeah, this should basically work, and that looks pretty nice. So let me just zoom in a bit so that you can see everything a little better. Anyways, this should work, and let's just let it compile and open up Unity. And once it has compiled everything and reloaded the assemblies, then we can try out how well that goes. So, currently our speed is not being taken into account, not that much of a problem. Alright, it goes to 0 immediately. That but doesn't make a lot of sense. The reason is that currently we have got a original scale of 0 as well, so we are going to set our original scale is equal to all scale in the start method, and let's see how well that goes. And so yeah, it's compiling, and let's hit play, and then it reloads everything, and hopefully this should work. I actually haven't. Okay, that is not something that we wanted. The reason that happened is because our target scale needs to be set to our original scale in the start method when we initialize our game. So this time it will, hopefully everything will work. So we are setting our all scales, original scale and our target scale to the same value. We can actually do it in a single line by saying all scale is equal to original scale is equal to target scale. We actually can make it a lot more concise doing this instead of what we were doing previously. That looks a lot better. So let's go here and compile, and let's give it a final try to see if it works or not. So let's just hit the play button, and hopefully everything will work fine. So let's see. Nothing happens. Okay, wait for 5 seconds, and it should start. All right, that's nice. Currently, of course, our speed is not being taken into account. All we need to do for that is that we need to multiply this. We can. I'm going to just multiply this value by. So we have got this here, and we need to multiply this by our time, scale speed. All right, so let's give it another try, and I'm going to try to increase my scale speed to something else and see what it goes like. Okay, let's just hit play, and once the game starts, I'm just going to go ahead and jump on this platform and stand in the middle perfectly so that I don't fall when it scales. Okay, it scaled, and it scaled faster, and it scaled in a great way, and it should scale back up like that as well. So yeah, you can see that it's kind of a nice obstacle to have. Sometimes you might want a scale of 0 to make the obstacle completely disappear and the player will left hopeless, and these can make into some really interesting puzzles. Now this is the basic overview of how you would create an obstacle, and you can create more obstacles if you want. I might make some more obstacles in this series, but what I would like to focus on in the next video, because I'm going to end this video here, what I would like to do in the next video is actually implement a coin collection system along with a coin model. Now give your thoughts in the comments below if you want me to actually make a tutorial about modeling as well, a separate series, not in this one, but I'm going to give you a link to download that for now, but download the coin model. But yeah, I might make a tutorial series about modeling stuff for games in the future in Blender. So yeah, this is all nice. So this is pretty much it for this video. Make sure to like and subscribe, and I will see you in the next one. Bye.